Thank you all for making it to this talk. I know it's the last talk before lunch, so bear with me. We'll get through this. I hope it won't be, I promise it won't be boring. How eye tracking can be the beginning of the end of privacy. I apologize slightly for the sensational title, although there is some nuance in it. I'm saying can be the beginning or may be the beginning, and in fact we might even be that privacy might itself kind of might have ended, but we're going to explore kind of like what it means with augmented reality and virtual reality, and the sort of data that you generate with AR and VR, and how that relates to privacy. So the overview: AR, VR are at the frontier of intimate user data generation, and are kind of the most risky form of data that, if it falls into the wrong hands, could lead to really bad things. So AR and VR, I mean, it's funny because like privacy and ethics in tech is a really big topic now, although it doesn't get discussed from the AR VR perspective at all. Mostly because I think people just don't have much experience with it, right? I don't know how many of you are here that do, but eye tracking is kind of going to be the central core of my argument, and what sort of a milestone that is in terms of this topic. So I'm going to talk about why it's important, why it's inevitable, where are we today, and as developers, what could and should we do about it. I don't disencourage anyone to take notes, but these slides will be available to download at the end. I'll have a QR code, so you can just pull them up that way. But do whatever you like to do. So who am I? I'm Azad Balabanian. I'm the host of the Research VR podcast, which is kind of why I've been invited here. And the podcast is mostly about kind of the science and design of virtual reality and spatial computing. So we invite designers, developers, founders of really interesting companies to come and give their knowledge, like to share their knowledge of what they've learned in this industry over the last few years from a more of a technical perspective. We like to kind of like dig deep into interesting topics, and one of those topics has been privacy and eye tracking, and this has been something that I've been thinking about for a while, but I haven't had any real conclusive thoughts about it, and so this talk really forced me to like do more research, go in deeper, and to like try and generate some sort of a conclusion that at least I can present here. So we'll see if I got to that. I'm also the director of photogrammetry at a company called Realities.io. This is a VR company where we do a lot of 3D scanning to create like photorealistic environments for you to explore in VR and AR. So we're mostly doing a lot of B2B work. But we're probably not going to talk too much about photogrammetry. Last year, when I spoke here last year, I did talk about photogrammetry and volumetric filmmaking. That's on YouTube. I would recommend, if that's something that you're interested in, check it out on YouTube. So this is a podcast. And so actually a lot of what I've learned that I'll be presenting here today has been stuff that I've learned from our guests. So that's kind of the benefit that I have, that I can, suck out the knowledge of really brilliant people from their like domains of expertise, and for me to kind of have a cohesive understanding of like where we are and where we should go. So bias in AI. I think this is the theme of the entire talk. I know nothing about bias in AI, so I won't be talking about that. But it's related. I think the theme of like unforeseen consequences in tech is kind of central to this argument. And so that's kind of the perspective that I'm taking. Who here has tried AR and VR? Show of hands. Awesome, that's a great amount. Who here has developed for AR and VR? Has done anything? Cool. So this is perfect, because I was hoping that I would come here to talk about two people that know a little bit about AR and VR, but are not like full-time developers with it. I don't blame anyone that isn't, because it's still a very new industry. Well, there's nothing to blame, obviously, but it's just extremely new, and it's not very apparent as to why you would need to have an AR VR headset at your desk as you're working in tech. So I think over the years that'll start to change. So what I am here to talk about is kind of biometric data in AR VR and why it's important. So let's, just go into your mind, like let's take a look at the tech news today? Like, what is it typically about? It's all about, oh man, Facebook is messing up again. Oops, sorry. Facebook is messing up again. You know, they're selling all your data. There's a huge amount of data breaches. And there's enormous amounts of wealth being generated. And tech is, I mean, I would argue the most influential industry in the world today, and it has kind of generated the most amount of wealth. So it's clearly an incredibly important industry to be quite critical about and to take. I mean, we're all in it, right? And so we have to like be critical of ourselves. So the main thing, again, are the unforeseen consequences that end up driving the news cycle about tech. So let's, this is just, I think yesterday or 2 days ago, I was looking up some data breaches that we can kind of look at. The video should be playing. So this is January, February news, March. These are all different sorts of data breaches. So if I can even stop the video, we can take a look and see like how serious they even could be. 7-Eleven Japanese customers lose $500,000 due to a mobile flaw app. Bluetooth exploit can track and identify iOS, Microsoft mobile devices and users. So there's a varying range of different breaches, but like clearly data breaches are prevalent to say the least, and they do and will happen. So keep that in mind as we kind of move forward. You know, I know security is a big topic in this conference here, but you know, so keep in mind that data breaches happen all the time. Why is eye tracking necessary and inevitable? This is another core central theme to my argument. Well, I'm going to give you 3 kind of reasons for that: the technical reasons, the design and interaction reasons, and the social reason. So let's start with the technical reasons. There's something called foveated rendering. And so these technical reasons are going to explain kind of why the headsets need to have eye tracking for them to even function correctly. So it's not just an entirely a bad thing. You know, it's not just being placed in the headset to like track you and to like exploit you, but there's actual huge benefits that we gain from eye tracking. So the first thing, kind of the first technical reason, is this idea of foveated rendering. Before I show you exactly what it is, I'll just quickly say that like even though our vision seems extremely clear to us, like all sorts of angles, the periphery of your vision is actually super low resolution in your eyes. That's because when you want to look at something, you look at it directly, and kind of your focal point is the highest resolution area, and everything beyond that starts to lose, like drop in resolution and color. So in VR and AR, when you're putting a display right up to your eyes, your eyes are extremely high resolution, and you can notice pixels. So you need to increase the pixel density of a display to the point when it's like, you know, over 4K displays per eye running at, you know, over 90 frames or 120 frames a second. So the compute requirement for that is really is a tall order, basically. Foveated rendering takes advantage of your eyes' basically low resolution periphery, and so if you know where you're looking, you can basically only render at the highest resolution where you're looking, and all the periphery around that is basically, you can reduce the resolution gradually. So here you can see with eye tracking you can determine where the user is looking. They're walking around, and so gradually those concentric rings kind of show how the resolution drops off. So this really can reduce, I think, from what I've heard, the compute requirements like up to 50%, which is a huge deal for VR, where like we need, like, you know, as of 3 or 4 years ago, you needed like a really powerful gaming computer to run it, and nowadays, you know, it's a mobile device that can run it, but still, all developers would like to have more room to play with. Another reason why you'd want to use eye tracking in VR headsets is something called simulating depth of field. So depth of field, you're probably familiar with it from films or from cameras. You know, don't forget your eyes are cameras. So if you look at something up close, everything behind that object is blurred out. That's just kind of how the physics of how light works. Depth of field is a strong, it's something that our brains are really used to, which is also why we like it in films, and it gives you the sense of scale. Like this is like a tilt shift looking thing, although it's a real model, it's not a real world. But in VR, because of the display tries to render everything at full sharpness, at the highest sharpness, because of the way the kind of the optics work today. That might change in the future, but a kind of a stopgap technology is to understand where the user is looking and to, in software, blur out the background behind that object. So here, this is Oculus's, or Facebook's Reality Labs. Is it playing? Yeah. Where if you can determine where the user is looking, you can really play with the right depth of field. So this is something called deep focus. And it really helps you ground yourself in that world that you're in. It just feels more natural, and it should be less eye straining. And in fact, right now in VR, you can't really bring objects too close, because technically you're not really focusing at the aperture in your eye isn't really focusing at anything that could be so close. So with technology like this, it really helps. So another reason is the ergonomics and comfort. So you have something like something called auto IPD adjustment. So everyone has varying distances between their eyes, whether it's narrow or wide. Right now with VR headsets, you have a dial you have to kind of like move. It pushes the screens or the lenses far and apart. But with eye tracking, you can just determine what your IPD is automatically, and it should just adjust automatically. You shouldn't need to have that overhead of like measuring your IPD before you get into a VR headset to have a proper fit. Another really cool feature that comes from eye tracking is user authentication and security, continual user authentication and security. I don't have a cool clip to show you, but check out all these cool iris recognition things. So we've kind of seen these in movies or in like super high tech vaults where you have someone goes up and puts their eye against the camera, it scans them in and says, yes, this is the person. Another form of this technology is kind of like back in the day, fingerprint sensors were super uncommon. They're only used for super high-tech stuff. Now almost all our phones have it, and it's a better way of unlocking your phone. Similarly, with eye tracking with a headset, you should be able to basically, when you put on a headset, the headset should know who you are, automatically adjust the optics to match you, and also continually know that it's you that's using this, right? Because right now with phones, once you unlock it, someone else could take it and you do whatever with it. And in fact, in some countries, like the police, if they can get you to like unlock your phone with your finger or your face, they can get into your phone. And so anyway, there's some ways around that, but at least with continual eye tracking, maybe that won't be as much of an issue. So the last kind of technical reason that would be interesting is the analytics and engagement side of eye tracking data. So up until now, like this is pretty common to have heat maps of websites. You either you have your own researchers or you can get a user research agency to come out and do some studies. This is a study that Toby did about, I guess, Match.com. It doesn't really matter, but it's basically looking at like gender differences between men and women, looking at dating profiles, and if there is like a significant difference. But the study isn't really the most important part. Today, with VR, that kind of takes the next step where you can really like have your users, your participants, look at a product, walk around a room, and you're really tracking like very specific things that they're doing, where on the box they're looking, how long they spend looking at it, and how do they interact with the people around them. And perhaps is there some sort of a can you influence the people around you to look at the same products or whatnot? So it's starting to get more and more advanced. This is another clip of this Toby headset. This is, by the way, this headset exists today. You can buy the HTC Vive Pro Eye that Toby has been working with them and building this. So this is mostly an enterprise tool for now because it still costs quite a bit of money. But it's, I think, just with the economies of scale, like these things clearly will have to get to the consumer, will be in the consumer level. One last example of this analytics and engagement. This is a friend of mine who also does some cool photogrammetry. So he made a 3D photogrammetry family album of him and his wife having this baby. So this is a scan of, like a 3D photograph, a volumetric photograph. And using a Magic Leap headset, he looked at the scan, and he did a heat map of where he was looking. So thankfully this is his wife, and it's not so crazy, but he's looking at the eyes, and then he's looking at her chest, and then he's looking at her crotch. So this is to be expected, right? Like, at the end of the day, let's not forget, we're monkeys. Monkeys look at other monkeys, and we're almost always looking for mates. So eye tracking is gonna, you can imagine this on every like Facebook image or Instagram image, and if you have like heat maps of where people are looking, like the sort of chaos that might cause. But we shouldn't be too scared about it, even though we will be. And you can imagine the articles that will come out about it. But when I saw this, I'd like tweeted out, I was like, and so it begins. Like this is almost like a pivotal moment of like humans realizing what humans are. So let's move to the second main reason, the design and interaction reason, or the possibilities that eye tracking opens up in VR and AR. So over the course of technology, we've kind of reduced the distance between intent and action. So first with terminals, you're typing in commands, to then developing a GUI and having a mouse and keyboard to, you move the mouse, and you're really directly showing your intent and what you want to act upon. So then with touchscreens, it became even less of a barrier that you actually get to touch the thing that you want to be interacting with. Then in VR, you actually get to grab the thing that you want to interact with. And finally, with eyes, you can even immediately show the intent of the thing that you're interacting with. So I'll give an example also of what that is. So it opens up completely new interaction paradigms. So this is also with that eye-tracking VR headset. This is a user in a virtual cinema sitting there. Is it playing? Come on, there we go. So from a distance, the user can interact with these objects. So whether it's the lights in the room, this random thing in the middle, or the sound controlling device. So this is a major problem in VR, is if the UI is beyond your reach, if you can't interact with it directly, there's kind of awkward ways of interacting with it, whether it's like ray casting or I don't know. There's multiple ways of doing it, but the dream is to be able to like look at something and like force pull it towards you and push it. Like, you can have these sorts of superpowers in VR, and those are the interactions that really make it all that special to do. There's another example of an interaction that you can do in VR with eye tracking. So the task is to throw a ball at these bottles, but it's pretty hard to have your aim be directly, or you have to practice to throw the ball and get really good at it. But imagine with eye tracking, you can actually just look at the target that you want to hit, and you just throw almost like a boomerang, and it goes and hits the thing directly. I can imagine video games and esports really or creating an entire video game where it's less about how fast you can aim your gun at the target, but how quickly your eyes can look at the target and you pull the trigger. So I think I can really imagine how interesting games could be once eye tracking gets integrated into every single end user device. So I've tried this in VR, and it feels magical. It feels like you have a superpower in your hands. Like wow, I get to really look at something and just throw my ball or throw an axe, and it hits directly the target that you're looking for. Superpowers. That's really the selling point of AR and VR from the interaction perspective. Social reasons. This is the third and final reason as to why I think eye tracking is really cool and interesting. Right now with VR, if you're in VR with another avatar, or you're as an avatar, your friend is in there as an avatar, you can interact with each other, and it's really interesting. If you feel like you're standing next to each other, you feel like you're present together. But your eyes are still kind of dead. Your eyes are either locked to your head, or they're locked to certain points of interest. If a developer did a good job building it. you can do some cool things with it. But with eye tracking, suddenly your avatar kind of comes alive. You can see them blink, you can see where they're looking, you can even tell if they're nervous, which is like, how cool is that, right? Like, you can have that really rich sort of interactions that you would in real life, and those translate directly into VR and AR. The social element of VR really, and AR, I think, are going to be one of the other selling point. Is you're going to be doing really cool things. This is the developer from Neos VR showing also the eye tracking and his application. So he just did a big eye roll, and you can tell he's like looking at the camera, he's looking somewhere else. It really brings like life to. There's also VTubers that are now using. VTubing is a term that's coming out of Japan that's like a virtual YouTuber. So instead of putting a real camera in front of yourself and like cleaning your room and cleaning your face to do a video, you could just embody an avatar and be a YouTuber as an avatar. So this is starting to become actually quite a big thing. Look up on YouTube, VTubing. It's big in Japan, as they like to say. So where are we today? Cue the "It's Happening" GIF. Today, this technology totally exists outside of research labs. This exists in AR headsets today and VR headsets. Not all the consumer ones, but Magic Leap's developer headset has eye tracking, and it's essential for it to function. The Vive Pro Eye, like the ones we showed, also have eye tracking. The Oculus Half Dome prototype that you saw has eye tracking. Google, notably, Google acquired a company called iFluence that was working on eye tracking to do user interaction design, and Apple acquired SMI, which was a major research company for eye tracking, and that was building eye tracking for VR headsets specifically. So clearly, all the major companies are moving in this direction and are going to be integrating eye tracking sooner rather than later. So another thing that most people haven't thought much about is our phones, our iPhones over the last 3 years have had eye tracking in them to begin with. So Matt Moss shows something that he was able to do with ARKit 2. So this is as of last year. He built an app where you can control the whole UI with your eyes. He built it as an accessibility feature, which I think is really interesting, but it just goes to show how accurate it actually is. I mean, there's like very specifically, you can see where the target is moving. So eye tracking is not just in VR headsets and AR headsets, but our phones have them now as well. I don't think it's on by default, by the way. It's not on at all times, and I think that's a power saving measure. But I can imagine a point in time where that gets less of an issue, and like even let's say your watch or something has attention. You know, it can detect attention and lights up the screen when you're looking at it, rather than you have to do a very specific gesture for it to light up. So we're definitely moving in that direction. And the last thing, actually, I ran across this like a week or two ago. There's a new research paper that came out about gaze tracking. So using machine learning, like training models on being able to detect where people are looking, the gaze detect on just a video. So this is from a TV show, I think The Big Bang Theory is what it is. And so it's tracking everything in the video, including the people in the masks. It's decent, I mean, it's pretty good at understanding where people are looking. It's not perfect, but check it out. Even the poster behind the people was being tracked, which is hilarious. So that brings us to surveillance capitalism, I guess. Like, clearly, eye tracking is not the only thing being developed. Like, there's other ways of understanding where people are looking, and there's like a lot of money in knowing that. So where are we today with surveillance capitalism, and what are like the main arguments behind it? Again, I've been reading a lot about this, but I haven't had solid, conclusive ideas as to like what's bad about it specifically. Is there anything illegal or unethical about it, and what we should do? So beyond it being creepy, why is it unethical? So Shoshana Zuboff, she's a professor at Harvard who actually kind of coined the term surveillance capitalism, and she recently wrote a book about it. So she argues kind of from a more almost like an econ perspective that data is the new oil, and that instead of the typical business model of like I buy something and I get goods for it, or I give you money and you give me goods, you give me something for free and I give you my information, and you can do whatever you want with it. So the main reason why she says it's unethical is because they're doing it in secret, and they go at length to kind of hide that. So it lacks kind of the being informed and consented, which, like the other eye tracking research that we saw with the heat maps, like that's all, you'd have to sit down, you sign a piece of paper, yes, I would like to, you can look at my eyes for as long as you want, just anonymize my data, blah, blah, blah. So she says, if you're doing it in secret, that's highly unethical, and they can use this to manipulate you, and they do use it to manipulate you. Another person that that spent a lot of time in kind of this ethics thing is Kent Bai. If any of you know this name, he's another VR journalist, and he calls himself actually an oral historian because he does a podcast with like all the major developers in the industry. So he actually wrote an entire like ethical and moral manifesto, and so the points that he makes are the asymmetry of power in the attention economy. So, you as a user, you're asymmetrically less powerful than the platforms that know so much about you and about the population in general. Then there's algorithmic inferences, which are never perfect. So even if they think they know what you want, it might not be totally right, which might be a good thing, actually. You don't own the data that you generate, therefore it might get used against you. And you're also prone to emotional manipulation. So that's an interesting conclusion that they both draw. And the third person that I want to cite is someone named Avi Bar-Zeev. He was one of the pioneers behind the Microsoft HoloLens. He's worked at Apple, I think on their AR team, although he won't confirm it. And so overall, nowadays he does a lot of like speaking about this topic specifically. So I'm trying to draw some conclusions from him. And so one of the things that he really pointed out that I hadn't thought much about is that you really cannot be anonymous with biometric data. If you can analyze someone's walking, their gait, you can even you can re-identify who that person is. In VR, everything is tracked. Your hands are tracked. Your head is tracked. Your eyes are tracked. So you can imagine like, with a few more bits of information, you can de-anonymize that piece of data. If the data is breached, like if your eye tracking signature, if your eye signature is breached, then there's really no changing the password. You can't, you're not going to get new eyeballs in your eyes like you do in Minority Report. So that data, he says, really should be local. That should never, ever, ever leave. And I think that's also how Apple does the Face ID and Touch ID. That signature never leaves your phone. Emotional manipulation can be extremely effective, and it puts you in a state of especially in a state of suggestibility. If you're being evoked with negative emotions from like articles that are very sensational, and they get you to react to them, then that really does put you in a state of like suggestibility to act on something. And this was an interesting point as well. The ad-based model, as they grow, they kind of need to lower their standards, because either, especially if it's a public company, they need to show growth. They need to also show growth in revenue. So either you have to get more users, which is hard to do for Facebook when they're already saturated. They almost everyone that has a phone, and so they're trying to give phones and internet to people that don't. Or you can make more money from each user. So to do that, you need to kind of lower the standards of like what you do with their data. So that was an interesting thing. And I don't know if it's like specifically can be applied to every instance of it, but I can imagine, I can totally see that like as an ad-based business grows, the standards kind of also have to change. So, the conclusions. What do we do about it? All this yapping and scaring people. I want to state that technology is inherently amoral. I think that's a really important point that today oftentimes kind of gets is not so talked about, because tech is in a state of like, it is in a weird state where like, tech is kind of bad, it's kind of good, but it's kind of bad. Like, what do we think about it? How should we feel about it? You should feel that it's amoral, and you should know that it's based on who's using it and for what reason. And let me give you a few examples as to what. Let's take trains for an example. Like, what is a train? On one hand, it's used to move people around for work, to home, to school. It has an enormous impact on productivity and GDP of a country. And now for climate change, it's also a really good alternative to driving cars or planes. So trains can be a really good thing. On the other hand, it has given nations the ability to move massive armies to conquer and given the ability to deport entire populations out of a country. So it's something as simple as a track, and the efficiency of moving things can be used for both good and bad. Another example, satellite imagery and Street View. On one hand, it gives us GPS navigation, location scouting, pathfinding, and historical archiving. On the other hand, thieves can use it to scout out rich houses and neighborhoods. You can look and find a house with a pool and be like, that's going to be the house that we're going to raid tonight. And finally, encrypted communications. On one hand, you can use it to communicate and organize against authoritarian regimes. And on the other hand, it can be used for terrorism and illegal porn. So again, it's inherently amoral. So I think it's all about the approach that you take as a developer. And one of the reasons why I'm even talking about it here is if you want any change to happen with a new emerging technology, it shouldn't be from the government's side. Like, if the government's acting on it, it's almost always too late. It's like way too many things have happened. We're now in the point of like trying to reel back the things that have happened, especially the same way that like the U.S. government is handling Facebook today. So it's important to have this discussion with developers because developers are the only like people that are going to be able to have the power to do anything about it and to like be ethical about it from the start. So as a developer, decide on what your principles are and publish them. This kind of sets precedent for your users to know what you're doing and what you're doing with that data, and if it's harmful to them. But I don't think that's the end of the story. I don't think informing really is the most. It doesn't change things because like people can be manipulated into accepting things. GDRP got passed, and now every website you go to has a pop-up that you almost always say accept, or you try to find the reject button, and if you can't find it, you just go for it anyway. So informing is not the last thing. Don't track data that you don't need to track, and don't store them. So again, because data breaches do happen and will happen, the best preventative risk measure you can do is to just not store that data. Or if you do need to use that data, do it locally and just don't store it in a database. And kind of the final conclusion is, if you are running an ad-based business, then explore if context-based ads can be equally as effective. This is also how DuckDuckGo is, this is kind of their business model is, they're like, we don't need to do behavioral ads for people. We can just use context-dependent ads. If you're searching for a car, I can give you car ads rather than knowing, oh, you live in San Francisco, you make this much money, so you must also like this, and that. I can't say that context-based ads are more effective than behavioral ads. In fact, I bet Google would say, of course not. Look at how much money we're making based on what we're doing, same as Facebook. But I think there's a moral argument to be made, and you as a developer get to make that moral judgment about what you want to do with your company. So. Thank you all for listening, and if you'd like the slides, there's a QR code where you can download them from. And if you have any questions, find me on Twitter. I think that would probably be the best way to find it. And the podcast as well, if you're interested in topics that relate to AR, VR from a technical perspective and society in general. Thank you.